Hello, my name is Clarke. I'm an academic at the University of Bath, and I'll be introducing FakeForward using Deepfake technology for Feedforward Learning. This is research conducted with Jingnan, Karan, Dharamshi, Harry McGill, Stephen Black, and Christof Lutteroth. So for decades, videos have been used as a tool for learning, training, and motivation. The low barrier to entry of video creation results in a wide range of instructors offering guidance on a plethora of skills. These are now easily accessible with modern streaming platforms. Videos facilitate something called modelling, where learners can watch a model performer execute a desired skill or activity, which we can then memorise and mimic later on. So when we watch somebody else do something, mirror neurons are activated, and these are thought to support and promote our ability to imitate others. Some research has also shown how the similarity between the model performer and the observer is a crucial aspect for the efficacy of video modelling. The more alike the model is to the observer, the more likely the observer is to learn effectively from the video. Video self-modelling is a special case of this, where it avoids the disparity between the observer and the model. In this case, the observer learns and watches themselves as the model performer. Feedforward is a special case of VSM, where people learn from a demonstration of a skill or behaviour of themselves at a level they have not yet acquired. This technique has been successfully applied across a range of physical skills, including swimming and weightlifting, and also communication skills for children with behavioural issues and academic and vocational issues. However, for practical reasons, current processes for generating these feedforward models requires the user to already have the skills in their repertoire. Videos are then edited to show these components arranged in a new sequence or placed in a new context. To address this, we present FakeForward, which combines feedforward video self-modelling with deepfake technology. As a result, we end up with personalised videos that can be used for training and that also allow users to watch themselves perform at a skill that they may not have yet acquired or performed. However, crucially, these skills or activities must not go beyond the user's capabilities. They must be realistic. This raises a number of research questions. So how can deepfake technology be used for video self-modelling? What areas of training and development can be supported with FakeForward? And we've seen from previous literature that VSM can be applied in a number of contexts, but what contexts apply to FakeForward with deepfakes? And finally, how effective is FakeForward in helping users develop skills? So we address this with development of both an ethical and a technical protocol for FakeForwards, and we conduct two studies, the first looking at physical exercise and the second investigating public speaking. So firstly, deepfakes have been used a lot for nefarious purposes. So we have issues with political misinformation, development of pornographic content without people's consent, and more recently it's threatened the very nature of the creative industry. As a result, we generated an ethical protocol that should guide the development of FakeForward videos. While they are a positive use case of deepfakes, it's important that we guard against potential misuse. So firstly, we need to be transparent about the potential benefits. We need to verify that people are creating self-models of themselves, because the underpinning concept is that these are used for private consumption. So we need to make sure that users are indeed creating self-model videos rather than videos of others. We need to protect an individual's personal data, because that's video data. We need to moderate the peer model content to prevent harm, to make sure users don't learn negative or harmful behaviours. We need to ensure the peer models are good quality, so both in terms of the technical elements, but also in terms of the skills that are learned correctly. We need to respect peer models' rights and copyright issues. And we also want to foster inclusion and fair participation of all people, so that we gain a wide variety of peer models for any given activity, for different abilities and such. We then developed a technical protocol inspired by existing literature, in which we developed and iterated on in the earlier stages of the research, where we tried to maximise the quality of the deepfakes. So we're going to assume that we're using face-swapping deepfakes for generating these, and participants should therefore look as similar as possible. So this results in the optimal fake forward videos. We need to be clear that participants know how the task is performed, and ideally they should face the camera as much as possible so that we see their face. Tasks should be feasible and adjustable to the participant's ability, and because we're working with videos, ideally performed in a slow, steady and controlled manner. Videos should also ideally have the same visual background and be recorded under similar well-lit conditions. In the first study, we investigated if and how FakeForward can support people performing physical exercises, so we chose 6 that target different muscle groups and different types of motor function, and we also selected a cardiovascular exercise. First, we gathered peer model videos from 8 different participants, and then using a different set of participants, we assess the efficacy of FakeForward. So we gather a baseline performance, which involves participants watching a tutorial video of each exercise and performing the required skill and then answering some questions. We then, after the baseline session, generated their FakeForward videos by allowing them to select a peer model that they felt was most visually similar in appearance to themselves. They were given a selection of models who outperformed them, so it's important that they're looking at someone who performs better but in a more realistic manner. And we used Deepfake Lab to generate the FakeForward videos. They undertook 2 more sessions after this, which were counterbalanced. The FakeForward condition involves watching the FakeForward videos and then performing the exercise, whereas in the peer model, they watched the original peer model video of someone performing better. So the only difference in conditions in the FakeForward, the peer model will appear to look like themselves. We measured performance as the time taken or maximum number of repetitions. We also measured identification using the video identification questionnaire as a manipulation check. And we also explored whether motivation, self-efficacy, or even flow could help explain any differences in the conditions. In all cases, we saw that performance is increased. And in 4 cases in particular, we saw significant improvement, statistically significant, based on our sample size. It was only the planks and press-ups that we saw a small effect that we couldn't statistically detect, and that could also be due to the positions. So participants lay down in the prone position, perhaps that could have influenced the effects of FakeForward. However, we did see significant improvements in the other 4 exercises. However, we didn't find any effects for motivation or self-efficacy. So that raises a question, what's the underlying cause of these performance improvements? When we look to the literature, the clearest example is that it's these mirror neurons that are potentially activating more strongly when a user watches a video of themselves. In the second study, we explored whether FakeForward is also effective in a psychological task, so we used public speaking as an example. First, we recorded participants giving a speech without any practice and to collect the video data for the generating of FakeForwards. We then created the FakeForward using a professional speaker video that looked similar to the participant. And again, we counterbalanced the conditions, so in one case they first watched the video of the FakeForward before presenting, and in the second case they watched the original recording of the professional presenter before the participant presents a public speaking. This time we measured how confident participants were when speaking, and we also used a rubric to evaluate how well they were at public speaking. Again, we measured motivation and identification. We saw significant increases across the board here. So we saw speaking performance go up, perceived competence, enjoyment, and importantly for the PRCS, we saw lower anxiety when speaking. So in total, FakeForward simplifies and democratizes the creation of video self-models, bringing these advantages closer to the general public. We've demonstrated how they're effective in both physical and psychological abilities, and as deepfake technology continues to evolve, it's going to open up exciting opportunities for FakeForward. Thank you for listening.